Hello, you are most welcome. I'm Teacher Ivan from Wuuna Educational Services. We are continuing with the logarithms. That is our first episode of O-level mathematics revision questions. Please don't forget to subscribe, hit the bell so that you get notified whenever we have a latest video, in order for us to move together and enjoy together. Please don't forget to comment so that we may know how we are serving you and where to improve. Also share with the classmates, family, and friends so that we learn together and enjoy together. We have so far looked at the first two parts. Our question says solve for x given that part A and part B have been covered in our recent video. Please, if you missed that, please, I request you to go to our playlists, look for O-level mathematics revision questions, and watch the previous videos so that we move together and enjoy together. Let us look at part C, which says log 8 power x plus log 8 power 2x equals to 1. Remember, the question is asking for finding or solving for x. In other words, they want us to find the value of x. So, in such a question, where we don't have coefficients, we shall go direct to the additional rule. But if we had the coefficients, just like in our previous parts, that was in part A and part B, we have to first deal with the coefficients before we apply the law of addition. But since we don't have coefficients, or the coefficients are 1, which is a silent 1, therefore we go straight to the addition rule, which says that when I'm adding the same bases, I simply multiply the powers. So that is, it will give us log 8 x, this is 2x into x. Because since we are multiplying, that is x times 2x or 2x times x, since multiplication is commutative. When we multiply, we end up with the log 8 2x squared equaling to 1. Still, we have two ways of solving this. We saw that in our previous part, that was in part B. We said that one way of solving this is by bringing in a law which says that if I have log A base B equaling to C, just like ours, it is in this format, then A equals to B power C. So if we compare our last step with this one, that means that A is equivalent to 2x squared, and B is equivalent to 8. C is equivalent to 1. And therefore, in this, we are substituting. Where there is A, we shall write 2x squared equaling to, where there is B, we shall write 8. This is 8 power 1. Any number to power 1 is that very number. Therefore, that gives us 2x squared equaling to 8. We divide by 2, we end up with x squared equaling to 4, and then get the square root of both sides, so that we end up with x equaling to 2 or negative 2. Remember, the square root can be either positive or negative. However, in logarithms, in bases, we consider the positive root for logarithms and bases. So that will be x equaling to our 2. So that is one alternative. The other alternative could be, we come back, remember our last part is log 8 power 2x squared equaling to 1. We have so far looked at one way of how we solve for x in this case. The other way could be, we can change the 1. Remember, we have a law which says that if the base is the same as the power, then that log equals to 1. And we see our base is 8. Therefore, that means that this 1 is the same as log 8 power 8. So, implying that we are replacing 1 with the log 8 power 8. So that is log 8 power 2x squared equals to log 8 power 8 instead of 1, whereby we now cancel the powers, we cancel the logs and remain with the powers. So that gives us 2x squared equaling to 8. We divide by 2, we end up with the x squared equaling to 4. That is 8 divided by 2. This is 1, this is 4. And then we get the square root of both sides, hence giving us x as 2, just like before. So those are the two alternatives of finishing such a number. We come to part D of number 3. Remember, our question is asking us to solve for x, or finding the value of x. Part D, we are given log 12 power x plus 9 minus log 12 power x minus 9 equaling to 2. Still, our coefficient here is a silent one, which we can ignore, and therefore we can go straight to the subtraction rule, whereby when we are subtracting logarithms of the same bases, we simply divide the powers. However, it's the first power divided by the second power. That is very important. Therefore, we shall have log 12 x plus 9 over x minus 9 equaling to 2. And still this one is in the same format, just like part C, whereby this time around I'm not using both, I'll use one. So from log A base B equaling to C, then A equals to B power C. So if we compare this with our last step, which is log 12 power x plus 9 over x minus 9 equaling to 2, if you compare, the whole of this bracket is equal to A. Then the base is B, which is 12, and then our C value is 2. So That means that x plus 9 over x minus 9, which is our A, equals to 12 squared. So this one is in the position of A. Then 12 is in the position of B, and 2 is in the position of C. We continue. This is the same as x plus 9 over x minus 9 equaling to 144. This one is a fraction. We can also make this a fraction. You get x plus 9 over x minus 9 equaling to 144 over 1. We cross multiply, collect like a terms, and find the value of x. That is to say, we shall end up with x plus 9 times 1 equaling to 144 into x minus 9. So we open brackets, that is x plus 9 equaling to 144 x, then 144 times 9 gives us 1296. We collect like a terms, whereby the x value, those with x or the x terms will go to one side and the constants to also one side. So we can bring this, or since we have this negative, we can carry to the other side to become a positive, thereby giving us 9 plus 1296 equaling to 144 x. This is a positive, becomes a negative. Hence, if we add 9 plus 1296, that gives us 1305 equaling to, we subtract 1, we get 143x. For us to get the value of x, we divide by 143. We reduce and get x as 1305 divided by 143, that is 9.126. That is to 3 decimal places, or it is also 4 significant figures. So that is how we solve in this case. Let us look at our last part of number 3, which is part E. Part E is a bit different, which makes it interesting. In our part E, x is given to us as a power. However, when a number appears in such a form, it can be worked out in 2 ways, depending on how it is said. One way is the use of indices. Assuming the base 5 and 7 was to be simplified to a common base, then we could use indices. Let me set an example of what I'm talking about. For instance, if we have 3 power x equaling to 81, this one is in the same format just like our number. However, this one can be worked out by 2 methods. We can use logarithm or we can use indices. But this one has only one method, which is logarithms. Indices cannot work here. Then let us see why indices works in this and not the other. Indices only works if 81 can be expressed in terms of 3. That is to say, we shall have 3x equals to 81 is 3 power 4. That is, when you decompose 81 by 3, you get 27. By 3, you get 9. By 3, you get 3. Then by 3, you get 1. So 3's are appearing 4 times. That's why we have 81 written as 3 power 4. Now here we shall be having the same bases, whereby we simply cancel them and remain with the powers, hence giving us x as equaling to 4. That is, in case these two can be simplified to have the same base, which is impossible in this case. So where it cannot be done, then we can apply logarithms. That is to say, our number is 5 power x equaling to 7. So we cannot use indices in this, simply because we cannot express these ones in terms of the same base. So we shall introduce log base 10 on both sides. That is to say, we shall have log base 10 power 5 power x equaling to log 10 power 7. And now, when we introduce log base 10, that forces x to come down, so that we get x log 10 power 5 equaling to log 10 power 7. Since we are interested in finding the value of x, we shall divide by log 5, thereby getting our x as log 7 divided by log 5. You can use your calculator. However, as you're using your calculator, make sure it's in degrees. How do you know that? It must be showing a capital D somewhere on the top tax bar. So that is log 7 divided by log 5. We have 1.20906. Sometimes they dictate the number of decimal places or the significant figures. I'm raising to 3 decimal places or 4 significant figures. This is, I'll round off, that is 1.209. This is 3 decimal places or 4 significant figures. What makes 0 a significant figure? It's because it is embedded or trapped between significant figures or non-zero digits. So this is to 3 decimal places or 4 significant figures. That has been our number 3. Please don't forget to subscribe so that we learn together and enjoy together. Like, comment, and share. See you next time. Bye-bye.